Good afternoon, everyone. And once again, welcome to session, which is session 3 of the training program for the seniors who are going to participate in the second round of the South African Mathematics Olympiad 2022. We have completed 2018 paper, all 25 questions, and we did 2019 up to problem 18, I think. And today we will continue with problems 19 to 25 of 2018, and thereafter we will move to the 2021 paper. We're going to skip the 2020 paper, move to the 2021 paper, and try to do as much as we can in that paper. And whatever we cannot complete, we'll try to complete it next week, which is going to be the last of the training sessions. Okay, with those introductory remarks, I just want to point out the house rules. I would appeal to you to make sure that you are muted from your side. The bottom left-hand corner of your rectangular screen has got a mute button. Make sure it is crossed. We don't want to have any disturbance while we are in session. Okay, I'm not sure if my good friend Patrick is present here, but if he is, welcome to Patrick or David from the South African Mathematics Foundation. Okay, as usual, we would not entertain any questions, largely because we have a large class, but we will entertain questions at the end of the session, that is around 6 p.m. All right, today we've got some rather difficult heavyweight problems, and we're going to take some time over the first few problems. These are the last few these are the last few problems of 2019. Okay, so go to. All right, so the very first problem, I trust that all of you have gone to have tried some of these questions, even if they were difficult. At least you have tried it, and therefore I trust that you would be familiar with these problems as we go through them. So the first problem says AB is a diameter of the circle that is given here. Okay, so what we have here is AB, there it is. It's the diameter of the circle. The center of the circle is M, that's the center. CD is a chord, and it is parallel to AB. So we have the following. This is parallel. Always try to write down the given information in the diagram. Okay, so it's parallel, and it meets AD at the point E, such that AC equals EC. So these two are equal. And the question is to find angle CAM, that one. So what is that? What is the angle? Okay, and interestingly, not a single angle is given here. That can be quite worrying. Without knowing a single angle in this problem, we are asked to calculate one of the angles. And there are just two pieces of information given. This is parallel, and these two, CE is equal to CA. Okay, so let's just get on to my next slide, where Now, to solve this problem now, we have to use the fact that this is parallel. Okay, that can be done because you've got alternate angles. Yeah. And this is the center of the circle. It turns out that as it stands, you can solve it as it stands, but it works out that it's much easier to have a construction to join M and D. When you do that, a lot of things work out quite nicely, because then you have 3 radii and there will be lots of isosceles triangles. All right, so let's have a look at the diagram here. So I've got 2 diagrams. It seems to me that maybe the one diagram has got no construction in it. So let's try to see why. Let's see whether we can do it without any constructions. All right, so we have to name some angle. As we said that CE is equal to AC is equal to EC. So these 2 angles are equal. Let's call this angle here X. A small angle there. So what does it mean? If that is X, oh, I'm sorry. Let's not call that X. Let's call something else X. Let's call this angle here X, because then we have alternate angles, you see. These lines are parallel. So if this is X, this angle here is X. Okay, so what happens now? Let's call this angle here Y. All right, and these 2 are equal. So therefore this will be Y. Okay, which means, because if 2 sides of a triangle are equal, then the angles opposite them are equal. But if you look at this triangle here, this is the exterior angle and exterior angle of the small triangle. And this is X here. So when these 2 are added, you're going to get Y, which means that this angle here has to be Y minus X. This angle here. When you add Y minus X to X, you're going to get Y. So this angle is Y minus X, which means that, again, now this angle, because these 2 lines are parallel, this angle is Y minus X. This also has to be Y minus X. Okay. So now you have that this is Y minus X. Now you'll notice that here you've got Y here, but when these 2 are added, you should get Y. And okay, so that doesn't give you any new equation, because Y minus X plus X is equal to Y. What else do you have? Because these 2 angles are Y, it means that this angle here is 180 minus 2Y. This 3rd angle in this triangle. 180 minus 2Y. Okay, but now, if this, why is it 180 minus 2Y? Because these 2, in this triangle, 2 of the angles are Y. So that angle will have to be, the 3 angles add up to 180 degrees. So this has to be 180 minus 2Y. Okay, but now MC is equal to MA, because these are radii. MC is equal to MA. So this triangle MCA is isosceles. So this angle here, which we just calculated to be 180 minus 2Y, that angle will have to be equal to Y plus X. Okay. So what does this mean? So this angle, so now we have an equation involving y and x. Okay, it means that 3y, bring the y's to one side, is equal to 180 minus x. All right. What else do we have? But these are isosceles. In this triangle here, in CAD, you've got all the three angles. They add up to 180. Let's see whether that gives you anything worthwhile. No, it doesn't give you anything worthwhile. All right, so it kind of stop there, and we can't proceed too much on this. Although I thought we might be able to do that. I seem to have forgotten how to do that from here. Okay, we got all the angles in terms of x and y minus x. All right, look, it seems there's something here, there's some way of getting to this without any construction, and I can't seem to figure out which new. I can see co-interior angles add up to 180 degrees, but very quickly I see that you don't get an equation. You'll get 180 equals 180 when you do that. That's not going to help. Yeah. All right. Okay. But let's go to this diagram where you join these two and see what happens. So again, let's call this angle here x. So this angle is equal to x, right? Because these are radii. See, now you got three radii. Now x, this angle here is x because you got a z here. These triangles, these angles are alternate angles. So now you have that this angle is 2x, but these are equal. MC is equal to MD, so therefore this will be equal to 2x. Now I understand why. You see, those people who have done circle geometry will know that the angle at the center equals twice the angle at the circumference. So if you look at this chord here, this chord, it subtends angle x at the circumference, and it subtends angle y minus x at the center, which means that y minus x, which is the angle which is subtended by the chord CA at the center, is equal to twice the angle it subtends at the circumference. But the grade 10s might not be able to understand this. But now you have your second equation, which says that y is equal to 3x. Y is equal to 3x. So if y is equal to 3x, then you can substitute y equals 3x here, and you get 3x, 3 times 3x. You see, wherever you see y, you can put x, so you have an equation with only one unknown. Right? This is a popular trick where you replace an unknown with something internal. Y is in terms of x. So 3x gives you 9x equals 180 minus x. That gives you 10x equals 180. There we have it. X is actually equal to 118 degrees without any other angle given. The problem was to find CAM. So we needed to find x plus y. That's this angle here. Always check to see what you are trying to calculate. So angle CAM is x plus y, and y is 3x. So this is 4x, and 4 times 18 is 72 degrees. So you can do it without any construction, provided you know that the angle at the center is equal to twice the angle at the circumference. Now this one here, this construction is grade 10s. If you have not seen that one, then we can do it like this. You get x, and this becomes 2x, and this becomes 2x because MC is equal to MB. Okay, and then you have that these two are equal here. Okay, and if this angle is 2x, this line is parallel to this, so this is 2x. These are alternate angles. And now these two angles here, the sum of these two angles is equal to the exterior angle, which is 3x. And if you look at this triangle, this angle, this thing here, this arm, which is set out the interior angles, that's the exterior angle. So that becomes 3x. Now you know these two are equal, so this is 3x, yeah? All right. Okay, but now one other thing here, you see MC is equal to MA, and this whole angle is 4x, and therefore this angle here is 4x. This angle here, because MC and MA are radii, so they are equal, and therefore this angle, this whole angle is 4x, therefore their angle is 4x. Now you got, in this triangle, you got only x's there, and if you add those three angles, you will get 10x equals 180, and that's exactly what we had earlier on. 10x is 180, and you can go on to calculate the angle CAM. So I've given you two methods of solving this. One uses the angle at the center equals twice the angle at the circumference, and this one here does not use that at all. It uses only isosceles triangles, but you have to draw a construction. All right, you have to join this. That way you get lots of isosceles triangles, and you can do this. So the important thing is that we don't know any angles, so name one of the angles x. Now, why did I choose this angle as x? Because it looks very small, right? Then all the other ones will be bigger. Otherwise, if you take a big angle to be x, then you're going to get fractions. So it turns out it's very nice because all the other angles are multiples. See, x and 2x and 3x and 4x and so on. If you choose the smallest one to be x, then it helps a great deal. Okay, so that takes care of problem 19. And we can get on to problem 20. Problem 20 says two parallelograms with perpendicular heights 5 and 10 respectively overlap at an angle of 30 degrees. Right, now you can see these are parallelograms. The opposite sides are parallel. That is what you mean by a parallelogram. It's a definition of a parallelogram. You are given that somebody has got the mic on. I'm going to just check to see who it is. Please check to see that your microphone is off because somebody is interfering. Please do that. Okay, so we've got the heights of these triangles. You can see the perpendicular height. So the perpendicular height is, we've got a parallelogram. The height between two parallel lines is the perpendicular height, like that. See? And the height between any two points, all these heights are the same because the parallelogram, if the lines are parallel, they are, no matter where you take the point, it will have the same height as the others. So in this triangle here, the height of this slanted parallelogram is that way, and the height of this other one is 5. So they give you those two. They also say that these parallelograms, they overlap at an angle of 30 degrees. So this thing here, you can see this angle here, the angle from here to here is 30 degrees. Right? And the question is, what is the area of the shaded overlap? What is the area of this? Okay. And the area of this, now this is also a parallelogram. So the first thing we ask ourselves, if you need to find the area of the shaded part, right, what do we need to know? So how do we find the area of a parallelogram? There is a simple formula for the area of a parallelogram. It's equal to base times height. In any parallelogram, the area is equal to the base multiplied by the height that is drawn to that base. What does that mean? That it means also mean that if you choose this as your base, then you have another height. If this is the base, we call this B, then the height here will be like that. So the area is also equal to that base times that height. So remember, you can choose either of the sides to be the base, but you have to, then you'll have two different heights. Okay, but the product of the base times the height will be the same. It will be equal to the area of the triangle of the parallelogram. So that's an important formula. So we need to know the base of this and the height. We already know the height of this one. Well, you can choose it to be either 5, or you can choose it to be this way, it's 10. See, if you choose between these two parallel lines, let me just get this right. If you choose it between these two parallel lines, then the height of this parallelogram is 10. But if you choose it to be between these two parallel lines, then the height is 5. All right. Okay, it turns out that it's better to choose this as your base for this parallelogram. So this is what I'm going to do. Let's get on to the solution. Okay, so what I've done is I've called the sides of this triangle X and Y, this parallelogram. So this is Y. And I've got Y here, and I know the height to be 5. So what I've done is I've chosen the height to be from here, from this one of the vertex. If you drop a perpendicular, that height is 5. Why did I do that? Because I got this angle here is 30 degrees. So now I have a small right angle triangle where I got 5 and I got one angle is 30 degrees, right? Which means I should be able to calculate Y. But the moment I calculate Y, then I can calculate the area because it's base times the height. So the problem now becomes quite easy. You got a right angle triangle, you got one side, you got one angle, and you need to calculate another unknown side in the triangle, right? And which ratio will you take? Those people in grade 11 and grade 12 will know that it's best to take the ratio 5. So you got 5 and you got Y. So 5 over Y gives you opposite over hypotenuse, and that is sine of 30. So sine of 30 degrees is 5 over Y. I'm not sure whether the grade 10s are familiar with all this, but the sine of 30 degrees, this is one of the popular angles. So I think there's a name given to it, is some special angle or something. And sine of 30 is a half. So 5 over Y is equal to half, cross multiply Y times 1, which is Y equals 5 times 2 is 10. So that is 10. So the base is 10. and the height is also 10. So the area of the shaded part is base times height, which is 100. 100 square units. I don't know whether they said they were in centimeters or whatever, but in general, it's 100 square units. Area is always in square units. Okay, now I thought I'd take care of those grade 10 students who have not seen trigonometry. So even you grade 10 students, you can also solve this thing, even if you didn't know trigonometry. But you have to do some construction. You see, I've drawn a little triangle here. Can you see this triangle here? What I've done is I've reproduced it outside. This triangle, which I am indicating, this triangle here, it's got 5, 30 degrees in Y. This blue triangle, I've reconstructed here, 5, 30 degrees in Y. But now you can still get the answer without trigonometry. If you take this triangle and you flip it around, there's a 90 degrees here. So if you flip it around, in other words, you reflect this triangle across this line, then, in other words, if you think of this thing as a triangle metal plate, then just turn it upside down and you will have the Y is here and this 5 goes here, and you have a new situation. Now, the thing about this is that these two triangles are now congruent, but it's the same triangle which are flipped around. Right? You can see what it's two angles, two sides and included angle. No, it's actually two angles and a side, 90, 30, and 5. Okay, so these two triangles are congruent, they're identical, which means that this side here is equal to this side. So that is why I got y, y, okay? But now this is an isosceles triangle and this angle is 60 degrees. So therefore, the sum of the other two angles will be 120 degrees, but they are equal now because these sides are equal. So each of them is 60. Right? But now this becomes an equilateral triangle. All the sides are equal, and therefore all the angles are equal. So therefore all the sides are equal. But this side here we already know it's 10. That's why y is equal to 10. See, you can do it without using trigonometry and trig ratios and not knowing special angles. But you have to perform a small construction like that, which will give you the answer again. But it's a nice, neat construction to show why y is equal to 10. The moment you got y equals 10, you can calculate the area. Okay, so now we get on to the next problem. So we go to problem number 21. A loaded truck travels from Durban to Pietermaritzburg at an average speed of 60 kilometers per hour. Okay, so you got two towns traveling and it travels at an average speed of 60 kilometers. So let's just say this is Durban and Pietermaritzburg. Naki, and a person called Naki, let me just get out of this for a moment. Naki Christina, can you please take your mic off? Otherwise, I'm going to take you out of the class. Naki, Christina, for the last time, please take your mic off because you are disturbing the rest of the class. If I hear you again, I will be forced to remove you from the class. Thank you. You see, valuable time has been wasted because I had to speak to the person who doesn't listen. Okay, you've got, I was saying that you've got a truck which is traveling from Durban to Pietermaritzburg And there's some information given about this. The information is, if you call these Durban to Pietermaritzburg, it travels at an average speed of 60 kilometers per hour when it's going from Durban to Pietermaritzburg. So the speed here is 60 kilometers per hour. And then after unloading, it returns by the same route at an average of 90, so it's traveling faster. The guy is in a hurry to get home. But apart from that, he had a load, so he can travel faster. It's offloaded. The question is, what is the average speed of the truck over the whole journey? Now, this is really a trick question. Most people will say, well, he's traveling 60 here and this is 90. So his average speed is 60 plus 90 divided by 2, which will be 150 divided by 2 and 75. And they will say the answer is 75. Turns out 75 is not the average speed, surprisingly. All right. And the reason for that is you have to understand what is the relationship between distance, speed, and time. We don't know the distance between Durban and Pietermaritzburg. Well, we do have an idea. Comrades is almost here. It's about 90 kilometers. So, but we're going to call it D. So on his forward journey, he traveled the 60 kilometers per hour. If you want to work out average speed, so what do you mean by average speed? This is the most important. Average speed is not the speed, not the average of the speeds. Right? That is a trap. Average speed is total distance traveled over total time. Distance over time is speed. Right? That is how you calculate the average speed, not the average of the two speeds. It's completely different. This is the formula for it. So the total distance he travels, it goes up D and comes down D. So that is, the total distance is 2D. Now, how long does he take? What is the total time? When he was going up, he was traveling at 60 kilometers in 1 hour, right? But he has to travel D kilometers. So the distance he travels is D, and therefore the time that he takes is distance over speed. Now this is in the denominator. I'm calculating the total time. The total distance is that. The total time is the sum of the two times. The going up time is D over 60, distance over speed. And the coming down is the same D because it takes the same distance. And this time is traveling at 90 kilometers per hour. So that's the time. And when you calculate this, right? I think the common denominator is 180. So I'm going to multiply right throughout by 180, 90 and 60. 180 times 2D is 360D. Multiply this by 180. 60 goes to 183 times. 90 goes to 182 times. And you got if you work this thing out, you got 360D over 5D, the D's cancel, and the answer is 72 kilometers per hour. So the answer is not 75. 90 plus 60 divided by 2 is 75. The actual answer is 72, and the reason for that is because you need to calculate the average speed in a very specific way. So you must be very careful. You have to calculate the total distance and the total time and divide the total distance by the total time as we have done. And you simplify that, and that's algebra, and you can get to the answer. Okay, so let's just get on to the next one. Oh, I left space for this, but I didn't use it. Okay, problem 22. Now it's getting a little bit heavy. The roots of this rather complicated looking polynomial. Now this is a cubic polynomial, and its roots are in arithmetic progression. What is the difference between the largest and the smallest roots? Now, what do you mean by roots? A root of any equation is a solution. In other words, what number must I substitute for x to make this thing exactly equal to 0? That's a solution. So the roots, so we don't know what the roots are, but we do know that the roots are in arithmetic progression. This is one of those problems where you cannot, you can solve it using pure mathematics, but it can take a very long time. You have to take an inspired guess and then check to see whether your guess is the correct answer. Let me explain what I mean by that. You see, 64 is 4 cubed. Four times 4 times 4. So let us try to factorize this expression. It is a cubic thing, so there is a great likelihood that it's a product of 3 linear expressions. By linear, I mean like mx plus c. Right? But since this is 4 cubed, it looks very much like this is 4x. You see, this is 4x times 4x times 4x. This is x cubed. So let's look at the very first term. Is 64x cubed. In all likelihood, well, this is a try, but we can guess that this is 4x, 4x, 4x. And the last term is 15. So that will be the product of the numbers at the end. So you got 3 numbers which multiply to 15. Right? And you can see the 3 numbers will have to be 1 times 3 times 5. You can have 1 times 1 times 15. But the fact that you are speaking about arithmetic progressions means this is a nice thing. It is. There's a common difference of 2 in these 3 numbers. But let's see now. If you put a 1 and a 3 and a 5, then those 3 will give you 15. But you want a minus 15. So let's put 3 minuses, and that'll give you negative 15. Now, you still need to check whether the middle term is 144 and 92. So you need to multiply this. And when you multiply all these things, right, you can multiply these to get a trinomial, multiply this by this, and multiply again, and expand the whole thing. And you will see that you'll get exactly this, which means that this is the correct choice. So you can check that product is equal to given. By given, I mean that stuff on that side. So now, once you factorize this, now it's easy to see what the roots are, which numbers will make this product 0. Here, so this has to be 0. X is equal to a quarter. And this has to be 0, or, and the third one, 4x over minus 5 is 0. And you need to just check to see whether these roots are in arithmetic progression. So you go to a quarter, you got 3 quarters and 5 quarters. So you are adding 2 quarters to get to this 2 quarters. You're adding another 2 quarters. So they are in arithmetic progression because you're adding the same number to get to the next one. So that roots are correct. And now the question is, what is the difference between the largest and the smallest? Always answer the question. So the largest is 5/4. That's the largest. And the smallest is 1/4. 5/4 minus 1/4 is 4/4, which is 1. So although it looks like a very difficult problem, you use some common sense and figure it out, because you can find the roots provided you factorize. You know, you do that with trinomials, right? If you can factorize it, then you know the roots or quadratic equations, right? The same thing here, factorize it. So you write it as a product. Factorize means writing as a product, but this time you're writing a product of 3 quantities because it's cubic. It means it's got 3 roots. See, when you've got quadratic x squared, you've got 2 roots. Cubic means 3 roots, so you have 3 factors. And after that, you do it as I described, and you can get to the answer. Okay, so let's just get on to the next problem. Problem number 23. It says that now given that f of 3, now f is a function, right? I presume that even the grade 10s have seen functions, right? What it means is simply it means you got an expression in one variable, but that means, like for instance, x squared plus 3x minus 25 or whatever. So you got x only. So you give a name to this, you put f of x, the function of x, because if you got some expression in x, you can write it like this, and this helps you a great deal, because when you are making a substitution, when you put x equals 3, then you say you put x equals 3 inside here, you say f of 3 is equal to, wherever you see x, you put 3, and then you can calculate 3 times 3 minus 25, and so on. And so this is what you mean by a function. And here, when you substitute 3 into the function, you're going to get 3. Now they give you some kind of a formula here, right? But you got the f on this side as well, and you got the f on this side. But the inputs here are n, and here by input I mean what are you substituting? You're substituting n in this case, and here you're substituting n plus 3 in this case. And they tell you that f of 3 is equal to 3 for all n. So in other words, there's just not one formula here. You can put any value for n, and you have a formula, right? So they ask you to determine this thing here, right? Now, one can get just naturally very scared when you see this, but you don't have to scared. You have an equation. Let's see what can we do with that, right? All right, so let's get to the next sheet where I have done some calculations to save time. Let me explain what I have done. See, this is what is given. And the question is, what is, when you substitute 2019 into your function, you add 19, what is the answer? All right. Now, the fact that I know what f of 3 is, that means I can put n equals 3 here. Let me show. I can put n equals 3 here, and then I will have f of 3, and I can substitute for that f of 3. I can substitute 3. Right? So let's put n equals 3, but then if I put n equals 3, this becomes f of 6, because then 3 plus 3 is 6. So that's what I've got here. When n equals 3, you got f of 6, 3 plus 3, and then n is equal to 3, this becomes f of 3 minus 1 over f of 3 plus 1. But now you know what f of 3 is. It's 3. So I can replace f of 3 by 3 by 3. So 3 minus 1 is 2. and 3 plus 1 is 4 because f of 3 is 3. See? This part here is equal to 3. So when you simplify that, you get half. So now you know what the value for f of 6 is half. So given f of 3 equals 3, you can calculate f of 6. Now, likewise, you can calculate f of 9. The reason being, if I put 6 in this equation, now I know f of 6, you see, so I can put n equals 6 into this, like the way we did earlier on. But on the left-hand side, you have 6 plus 3, which is 9. So I can calculate f of 9, right? And how do you calculate f of 9? If n is equal to 6 now, so you go to f of 6 minus 1 over f of 6 plus 1. F of 6 we've just calculated is a half. There it is, f of 6 is a half. So this becomes half minus 1 over 1/2 plus 1. That's how I've got these. I'm replacing f of 6 with half. So you can calculate f of 9. When you simplify this, you get 1/3 or minus 1/3. How do you simplify a fraction? You multiply numerator and denominator by the same number. Multiply everything by the same number. So here, to get rid of the fractions, so you multiply by 2 right throughout, and you'll get to this answer very quickly. So you know f of 9, and so in exactly the same way, if you know n equals 9, you can put 9 here, and you get f of 12. And when you substitute f of 12, do that, you get -2. Now you see I'm getting a half, -1/3, -2, and then don't give up. We continue to do f of 15. When you put n equals 12, you get f of 15, and then we know what f of 12 is. It's -2, as you can see here. Right? When you solve for this, you see you get the answer is equal to 3, which is the same as f of 3. So what does this mean? That when I substitute 3 into my equation, I get the same answer as when I substitute 15 into the equation. I get the same answer. Now, if I proceed with this just the way we did there and go to 18, you can see exactly, if I work out what f of 18 is, I'm going to get a half. It's the next number. So what happens is that you've got f of 3, f of 6, f of 9, f of 12, f of 15, f of 18. If you just keep going on in threes, now we need to get to f of 2019, right? Because that's what we need. We saw that this is a half, this is 3, and this is a half, and this is -1/3, and this is -2. And f of 15 is 3. And now you can do the same thing here. The next one will be a half. The next one will be -1/3. The next one will be -2. And the next one will be 3. Because you keep substituting the same thing, and you will have this sequence here. So now the question is, you'll notice that f of 3, after 12 steps, right? When you add 12 to it, you come back to 3. So I'm going to put 3 in front. F of 3 equals 3, f of 15 equals 3. And you can see the next one will be 27. The next one will be 39. You keep going on like this. Right? So the question is now, when you got the numbers of 3 and 15 and 27 are all, when you substitute any of these numbers, you'll always get 3. You have to see now what happens towards the end there. See? So what you've got is that f of 3 plus, you got multiples of 12, you see, you got 3 plus 12, 3 plus 24, 3 plus 36. So it's 3 plus a multiple of 12. 12 something, right? Whatever it is, this is always equal to 3. Right? Now, this is where you can get quite stuck because you wonder, how are you going to use this? Now watch. The trick is to divide 2019 by 12. And when you work this thing out, you will get 168. The remainder is 3, which means I can write 2019 as 3 plus, because the remainder is 3, 3 plus the multiple, which multiple of 12? It's 12 times 168. And so you can write 2019 as 3 plus a multiple of 12, right? Which is very nice because it means that we know that 3 plus any multiple of 12, the answer is 3. In particular, 2019 is 3 plus a multiple. If you long divide, you can see the quotient is 168 and the remainder is 3, which means that 12 times 168 gives you 3 less than this. Then so if you add 3, you'll come to that. So now we know what this is. That thing is 3. And therefore the answer is 3 plus 19. The answer is 22. F of 2019 is 3. So the answer to the question is 3 plus 19, which is 22. Yeah, so you need not fright. Whenever you see things like this, you must try to see what else can you do. You know, you're given only this one piece of information. You use it to get something new. You use a new thing to get something even newer. And you keep going. Don't give up, because like if you are familiar with this kind of problem, it'll always happen like this. I know, I have faith that it's going to come back to 3, right? Well, all I need to know is when will it come back to 3? And once I know when it comes back to 3, I can see I have to add 12s all the time to come back to 3. And then I just have to divide your number by 12 to get to the answer, because you're adding 12 all the time. Okay, some people will say that this 3, 15, 27, and so on is an arithmetic sequence. And they are, you might have to calculate the nth term or something like that. I don't know whether, if you're sharp enough and you know what you're doing there, then you might be able to solve it. But I think the best way to do it is 3 plus a multiple of 12. And what is that? Divide by 12 to find out what the remainder is. Okay, so let's just go on to the next problem. Problem 24. When n standard 6-sided dice are rolled, the probability of obtaining a sum of 2019 is greater than 0. And it is the same as the probability of obtaining a sum of S. What is the smallest possible value of S? It's quite difficult to actually understand what this question is saying as it stands, because now you got probability that you're getting a sum. When you're taking n standard dice and you're adding the sum of all the numbers which come on the top, and what is the probability of getting the sum of 2019? And they say it's greater than 0, and is the same as the probability of obtaining a sum of S. What is the smallest possible value of S? All right, I'm going to show you the full calculation so that when you have a look at it in we will be sending the recordings to you, so you'll have this on the screen. I've worked the whole thing out. It's a difficult problem. In fact, it's a very difficult problem. But I'm going to go through this thing quickly, and in your own time, those of you who are interested can try to unravel this mysterious solution. Right? Let me go over this thing quickly. We've got n dice which are rolled. I'm going to take the simple case when you have only 2 dice which are rolled, right? And then try to understand what is being said in this problem. I'll roll 2 dice and I'm going to add the numbers that appear on it, because this thing here is saying that when you're rolling n dice, you're working out the sum. I'm going to make n equal to 2 and see, what's going on here. So you've got 2 dice. When you throw 2 dice, you've got several possibilities on the numbers that appear. You're going to have 1, 1. I've got 1 in the front. The first roll, n is the number of rolls, right? First roll, you get 1, and in the first dice, and you get 2 in the second one. So you could have 1, 1, or you could have 1, 2. X here is 2, you see. So I could have 1, 2. I'm taking the dice to be different. You got a left die at least. You got another one. So I'm okay. If it's 1, 1, 1 and 1, or you could have 1 and 2, or you could have 1 and 3, right? Which I'm treating as different from 2 and 1. 2 is on that dice. Maybe you got a red and green dice or whatever, and 2, 2, and so on. And I take each one of those possibilities and I add them, right? So yeah, you got 1 plus 1, 1 plus 2, 1 plus 3, and so on. Now 2, 2, right? Like for instance, if I take this one here, the first dice is 4, 5, and the second one is x. There's your x here, x is 4. The first number is 5. So here I am talking about the first dice has got 5, and the second dice is 4. And when you add them, you get 9. So 5 plus 4, right? So that's how I fill this entire table. Right. Now the question about, it's a question about probability. So the question is, what are the numbers that actually occur here? What are the possible sums, right? Now, for instance, these are the sums. So the numbers that feature as a sum of these things is that. So if you ask yourself, what is the probability? Now, remember, this is x. The sums are inside here. I should have separated these. The sums are inside this block here. Right. The sums, the lowest value is 2, that's 1 plus 1, and the highest value is 12, 6 plus 6. So the sums that you get with 2 dice vary between 2 and 12. And the probability of getting any one of them, how do you work out the probabilities? If you take out the probability that, for instance, you want to know what is the probability that 8 occurs. Okay, there are 36 numbers here altogether. 6 by 6 you've got, right? So you have to work out the probability of any one particular number. You have to count how many times it occurs and put it over 36, because there are 36 possible answers. So if you take the probability of 2, it occurs only once, and that is 1 plus 1. It occurs only once, so the probability that 2 occurs is 1 over 36. But likewise, the probability of 12 is also, it occurs only once, and that's also 1 over 36. So the probability of 2 is the same as the probability of 12. The answers are 1 over 36. Now, if you look at 3, probability of 3 is 2 over 36 because there are only 2 3s, right? But the other number which is occurring twice only is this one, see? So the probability of 3 is the same as the probability of 11. And in both cases, it's 2 over 36. So there it is, you got that. And likewise, you work out all the other probabilities. Probability of 4 is equal to this, and so on and so forth. Now, the question, what we're going to focus on is that the 2 probability is always the same. The probability of 2 is the same as probability of 12, and 3 and 11, 4 and 10. So what we have here is the probability of a number, say x. 2 plus 12 is 14, 3 plus 11 is 14, 4 plus 10 is 14. It's the same as probability of 14 minus x. Right? And x runs, the value of x can only be between 1 and 6. See? So the probability that 1 occurs is 0 because 1 can never occur. So if a number is not here, that means its probability is 0. And if it is here, it's got positive probability. So the probability that you can get 35 when you roll 2 dice, it can never happen, impossible. So the probability is 0. See? So these x's only vary between 2 and whatever. Right. But what I did was I decided that I want to stick in a 2, the n value is 2. So somehow I'm going to bring in the n value here. So if I put x equal to, you'll notice that you're looking at the x is 2, 3, 4, 5, 6, or 7. So why don't we say 2 plus something? So x is 2 plus k. And then what happens here is that 14 minus x it's a difficult problem. It's 12 minus k. And now the 12 is interesting because it features the 6. This is 6 times 2 minus k. So if I replace x by 2 plus k, I get this. Probability of 2 plus k is equal to probability of 6 times 2 minus k. So the 2, which is the number of dice, it features here. Right? And 6 will always be there because the dice has always got 6 faces. So 6 will always be there. And this k can be anything. You know, as we saw, k could be 0 or 1 or 2 or 3 or 4. You'll have this formula working for all of them. Right? So k can be anything, but this is your n. So that is how I say if you got n dice, you'll have the same situation. The n is equal to 2. And here you have 6n, 6 times 2 minus k. Right? So this is, you'll see that 2 numbers have got the same probability. Right? Whenever you throw the dice. And if you go back to this question, now we've got a better understanding of this question, hopefully. It says that the probability of obtaining a sum of 2019. Now we saw that with 2 dice, you can never get 2019. So you need to have a lot of dice to get this, right? So the probability of getting a sum of 2009 is greater than 0. In other words, you have sufficiently many dice to get a positive probability. See? Okay. Now, let's see now, what's the least number of dice that you can have to get 2019, right? We saw with 2 dice, the largest possible sum you can get is 12 because you get 6 plus 6. So the question with 2019, you need to have a lot of dice. So you need to have how many 6s are there in 2019. So you have to divide by 6. Remainder 3. I'm sorry, remainder 3. Okay, I'm doing it quickly. So if you got n is equal to 336, right? And you get all the dice are showing 6s. 6, 6, 6, 6, the highest sum. And the last dice has got a 3 on the top. Then you'll get 2019 for the very first time. See? So if you got a fewer, if n is less than 336, right? Then the probability that 2019 occurs is 0. Right? Because if you got fewer than 336 dice, then you're not going to get, you can never get 2019. So the question is, now, what is the smallest possible value of S? Now here, the question is slightly changed now. It says the probability of obtaining a sum of 2019 is the same as the probability of obtaining a sum of S. Right. Now, what is the smallest possible value for S? So you've got the probability of 2019 is equal to the probability of S, just as we have probability of n minus k, n plus k, is equal to the probability of 6n minus k. That's the formula we had. So now you got 2019, and you want to know what is the smallest possible value. All right, so I'm just giving you a general picture of what's going on here, because when you start writing the mathematics down, it becomes a little bit complicated. But understand that you are looking for the smallest possible value of n, which will give you a positive probability. So n looks as if n is equal to 336, because that's the smallest value where you get a positive probability. But this thing here, it prevents that from happening. I'll just show you what happens. If you go to the next slide. Go to the next slide. So we analyze P of 2019, we divided it by 6. And now what I did was, I wrote 2019 as 6 times this, but we need a 6n minus k in this formula. Now I got 6 times a multiple of 3, so I might as well say that I add one more 6 to this, right? But then you subtract a 6 from here. So if you add one more 6 to here, then you have to subtract that 1 6, you get minus 3. So now when n is equal to 6 times this, 337, what happens? Right. Now in this case here, when n is equal to 337, right, what happens? The probability of 2019 in this case is 6 times 337 minus 3. Right? I'm replacing 2019 by that. And that gives you, now you use a formula. 6n minus k, probability of 6n minus k is the same as probability of n plus k. So this is your n, 337, and there's your k. So 337 plus 3 gives you 340, right? So when you have n equals 337, right? When n is equal to 337, right, it will produce the value 2019. And it's the very first time that it will produce the 2019. As we saw earlier, 336 does not produce 2019. So n equals 337 is the smallest number of dice that can be produced that sum. Since for any smaller than this, the probability is 0, as I just said. Okay, and then so the smallest s, there it is, p. We want p of 2019 equals p of 340. And the question is, if you go back to this, the probability of 2019 is the same as the probability of obtaining a sum of s. And what is the smallest possible value for s? And this tells you that this is p of 2019 is equal to p of 340, and this must be the smallest possible value because it's coming from 337. But I've done some other funny looking things here, which is for the full marks. There are some other questions that need to be answered, but at this stage here, you can quickly say that the smallest possible value for s is 340. Okay, I'm leaving that on the screen so that when you see the solution, it's there for you. When you get the video, then you can go and try to understand what's going on there. Okay, so we now get to this last problem in 2019, and it tells you the following. Squares s and t are each placed outside a square of side A and inside a square B, like this. So you got one is placed here, and you got another square of side A, and you got the same one here. So here the square is drawn like this, where you in both cases you got a large square and you got a small square. And in one case the square is drawn at the corner, but here the square is tilted because they say both of them are squares. So the square is tilted here. On the right diagram, the diagonals of the square are parallel to the sides of the other two squares. So the diagonals, in this case, is parallel to this, and this one is parallel to that. So the diagonals are parallel. So to read this thing, the diagonals of square t, these are the two diagonals, they are parallel to the sides of the other two squares. Well, actually, any one square. Okay. Then they tell you if the side length of square S is 27, this one here is 27, right? What is the area of square? What is this area? Okay. Now I have to warn you that I must confess, I must have spent more than 8 hours on this problem because there were so many things which it's a very, very, it's got a lot of information in it, although it looks rather easy because there were some. But basically, let's before I tell you how difficult I found it, let me do this, show you how to do it. When I show you how to do it, you'll see it's very, in one case, it's rather simple. In the other case, it's not that simple, but still. And this is problem number 25. So now, the important thing here is that everything, all the action happens at this corner here. Right? So what I'm going to do is isolate the corner. I'm not going to worry about the A and the B. In fact, I'm not going to name these A's and B's at all. All I'm interested is in the square here. You got that, and then you got the diagonals of the square. This new square, I draw it. The new square goes through that point, as you can see. Right? In fact, that's the only common point in these two squares. But this point here, the side is sitting on that point. The other ones, we don't know where it is. Now, when the other vertices, they are somewhere on this boundary. One vertex is here, one vertex is here. Another vertex is below this line. So we're not too clear about the vertices, other vertices of this triangle, of that square. Okay, so now let's just go into the diagram. So there's your original diagram. And I'm looking at the corner now. Right? Look at the enlarged view of the corner. So there you got this, and you got that. Right? As I said, one of these this vertex of this thing, that one, that point there is sitting on this line. Right. Now we know this area is 27 times 27. So what is the area of this? Okay, now in this picture here, what I've done is through this point here, I draw a line parallel. I go right down, and at the bottom too, I draw a line which is parallel. So I draw a parallel line here, and I draw a parallel line here. And this new thing is a square. This large thing is a square. So in other words, what I've done is I've kind of embedded, if you want to use that word, these two into a larger square like that. Right? And then what I did was divided this original square into 4 equal parts. So in other words, I took this large square and divided it up into 16 smaller squares. And you will see that when you do that, provided so the original square is divided into 3 equal parts, but what actually happens is this new part is the same as that one. The extended part here is the same as that part. Now this is the thing which is not easy to see, right? But okay, but suppose you do assume that this extended part is like this, then you can see why this object here is a square. Because this is the midpoint. The outside one is definitely a square, right? Because 4 by 4. And this is the midpoint. So if you look at this line here, these 4 triangles are all congruent. This triangle here, this outside triangle, right? In fact, they are all right-angled isosceles triangles. and they're all congruent, and therefore all these are equal. So this inside here is a rhombus. All the four sides are equal. But more than that, because this is 90 degrees, these angles are 45. These are equal, you see. These angles are 45 here. Or otherwise, you've got a small square inside here. And the diagonal of a square, right, it bisects these angles. So this is 90 and this is 45. That is also 45 here. So this becomes 90. So it's a rhombus with one of the angles 90 degrees. So it's a square. So you got the picture you want, because when you join this, all you have to do is to join these four. Let me show you. Let's just get some colors here. So suppose I got a green and I join the large square, I join the midpoints of the opposite sides. What do I have? I've got four identical squares here. Four identical squares. Now, why did I want to have that? The reason for that is that this thing here becomes the diagonal of the small square here. And this one is the diagonal of this square, and you can see it must go through the center. Right? And this is, so it satisfies that condition there. It goes through this. This line here goes through that. So we've got exactly the same picture there. And now all we have to do is to calculate the areas of these two squares. And we know the original area, yes, this has got 9 squares in it, the original one. But what about this new one? It looks as if this new one is, it's actually altogether you got 16 squares. You got 16 squares, right? And to get this tilted square, those two give you a 2 by 2 square. So those two will give you 4 of these little squares. And likewise, these two, when you put them together, right, you will get, if you like, you can take this and push it up there, take this and push it up here, and then you have 8 squares, right? 8 squares. These 4 cover 8 squares. So therefore, the new square the original square had 16 squares. So the unshaded part in this thing here is 16 minus 8 squares, which is 8. So the new square, its area is 8, because the remaining parts can be made up into two of these 4 by 4, 2 by 2 squares, right? Which gives you 8 small squares. So the new square is the whole square minus those 8. And the original square was this one here, and that is, it's got 9 small squares. So the point here is that the area that you're looking for, the area of the new square, is 8/9 of old. The area of that is 8/9 of old. Okay. It's a smaller, although it looks as if it's bigger, this area is smaller than that one. It's 8/9. And the original side, as if you can remember, was 27. So therefore, the area of that square was 27 squared. Right? That's the area of the original square. And you don't have to multiply all these because you're not allowed to use calculators. So if you divide that by 9, 9 goes into this 3 times. 3 times 27 is 81. 81 times 8 is 648. and without having to use calculators and multiplying 8 by 27 squared and so on. You can just, I always work out complicated sums like this by using fractions, canceling fractions. Okay, so that is one of the ways of doing this thing. But I had another ingenious way of doing it. Even if I were to say so myself. I'm going to show you that method. The reason being that it's got a very good application of analytical geometry. Oh, what happened? No analytical geometry. Oh yeah, there it is. Okay. So I redraw my picture. And this time I don't draw a larger square. There's my picture, 27. I'm sorry. There's your original square. And this is the square that I've just drawn. Right? But now you'll see I've got a lot of other information inside here. What I do is I put this into a coordinate frame. In other words, I make this side here the x-axis, the side of the original square. We call this the original square. And this thing here is the new square. So I make one of the sides of the original square, x, and make that y. And now I use coordinate geometry to calculate the area of the square. Right, so that's an interesting application of coordinate geometry. Now watch. In the first place, you know that the side of this is 27, and this is the origin. So this point here has got coordinates. That is 27. Vertical is also 27. So that point there has got coordinates 27, 27. Now what I'm going to do is try to starting from there. Now, you know that this line here is parallel to that line. It is given that the diagonals are parallel to the original sides. So, which means that the y coordinate of this point here is 27. I'm sorry, the x coordinate. X coordinate for this point is 27. I don't know what the y coordinate is. So that gives you that. And then also this line here is parallel to this. So as far as this point is concerned, it will have the same y coordinate as this. So whatever the y coordinate of this is, the y coordinate of this will be the same. I don't have the y coordinate of this. All right, so we've got an unknown quantity here. You see this point here, we don't know the x coordinate for this, but we do know the y coordinate. So let's give a name to this x coordinate. We'll call it A. The x coordinate of this is A. Right? Now, here's a very important fact. This line here, which is the diagonal of your original square, it goes through the origin, and because the square, the diagonal is bisects the opposite angle, this angle is 45 degrees. So the equation of this, the slope of this is the tan of 45, which is 1. Right? Slope is the tan of this angle. So the equation of this line is y equals x. So this line here, its equation is y equals x. Now, let's just go into this picture here. If I take a point, now listen very carefully. You will come across this idea in somewhere in your school syllabus, but in a higher level. When you take a point in a with two coordinates and you reflect it across the line y equals x, then you know the coordinates of this point. The answer is, if the coordinates of this point are a and ab, then the coordinates of are ba. Strangely enough, they just flick around, and this point will have coordinates ba. Now, what's the reason for that? You see, when you reflect this, what does that mean? You are hitting it perpendicular, and these are equal because you are looking at this as a mirror. And when this ant is looking at itself in the mirror, it goes up to the other side, and these distances are the same, and you're looking at it vertically. So you get these two are equal. And then what happens is that this point here lies on the perpendicular bisector of these. But the point about this is that these two now become equal. And this is A, and that is B. Right? And these two red triangles, that one and that one, are congruent. The reason is this whole angle is 45 degrees because y equals x is 45. These angles are equal. These two triangles are congruent. The whole angle is equal to the other angle. So therefore, the remaining angles are the same. So what happens is that these angles are the same for the hypotenuse, and therefore these two triangles are congruent. But the moment you say they are congruent, it means that this line here is equal to that line. So that line becomes B, and this line here becomes A. See? So the x coordinate for this is B, and the y coordinate is A. So when you reflect a point across, the AB becomes BA. Now, why did I need all this? There's your y equals x, and there's your A27. And if you look at this thing here, this is perpendicular and goes across to the other side, right? So therefore, this thing here is a reflection. So the coordinates of this are 27 and A. See? And here, the y coordinate of this is A. So therefore, the y coordinate of this point is A. But the only thing is, you don't know what the x coordinate for this point is. But if you look at the x coordinate, you see, this angle is also, if I extend this line, like that, this angle here is 45 degrees, right? And now you got a line going through the origin, and the angle is 45, so it's got negative gradient, right? But the gradient of this line is -1. In other words, this equation of this line is y equals minus x, right? You know the y coordinate is A, so from the equation you can calculate the x coordinate by substituting, and you will have the y coordinate is A, so the x coordinate for this point is -A. So now you've got 3 of these points. You got their coordinates. There's only one unknown, namely A. But now you have this line here is parallel to this line, right? There are many ways of showing it's parallel, but we can see that they are parallel, and therefore it's got the same gradient as this line. Parallel lines have got the same gradient. But what is the gradient of this line? The gradient is y2 minus y1, 27 minus A over A minus A. That's the M value for this line, gradient. And that's equal to 1 because it's got the same gradient as y equals x. And now you've got an equation involving A, and you can solve for A. 27 minus A is equal to, this is 2A, A minus A times 1. You get A equals 9. 3A equals 27. So So A equals 9. So once you got A, and so this A value is 9. And now we are almost there, because the area that we are looking for of new square is equal to the side of this square here squared. So it's side squared, S squared. And this is a side. And the distance formula now kicks in, because the square of this, you know the coordinates of this is 9 and 27. And here you go 27 and 9. The square of that is y2 minus y1, 27 minus 9, all squared. 27 minus 9, all squared, plus x2 minus x1, that's 9 minus 27, all squared. And that gives you exactly the area, because it's the square of the side. And the square of the distance between 2 points is just the distance between 2 points, the square root of x1 minus x2 all squared plus y1 minus y2 all squared, if you know your coordinate geometry. So I'm using coordinate geometry quite often here. So this is 27 minus 9 all squared. That's 18 squared, and you can check it out to be 324 plus 324, and you get back to 648. That's the answer that we had earlier. Okay, now that's quite a mouthful. And I'm going to send you the, well, we'll post the this recording, and you'll be able to have much more time to have a look at this and understand it. It's, as you can see, it's quite a difficult problem, but towards the end of the of round 2, you have all these difficult problems. I don't know how much of time they give you. I think they give you 2 hours, and so it's not very fair. They don't expect people to get these. In fact, smaller than 0.5% of people actually get these answers, sometimes by guessing. But I've given you a thorough treatment of these problems, these 2 problems. But like that, now you'll have a lot of challenging problems. Okay, so that took care of all the problem 25, and we are finished with this. And now we can go down to the next paper that I wanted to look at, and that is 2021. This paper was sent to you, and I'm going to try to do as many as I can in the 20 minutes which I have at hand. Right? So I'm going to go quickly, because as you can see, I'd like to spend some time on the latter problems next week. That takes a lot of time. So let's just go through these. All right, so the first thing is problem 1. I'm not going to spend too much of time with this. You can see it's a 1-line problem, so I'm not even going to spend any time with this. But I have a diagram here also to explain that. So I'm not going to spend any time on that. Problem 2, 4 rectangular fabric strips. Okay, these are fabrics of length 10 centimeters. So the length of this is 10 centimeters and width 1 centimeter. In other words, that is 1 and that is 1. The width and the length, full length is 10. Full length is 10. Are put flat on a table and overlap at right angles as shown. So you got each one sitting over another one, as you can see. What area of the table in square centimeters is covered? Okay, so which area of the table is covered? Now, you can see this part covers is sitting on the table, and in between is sitting the table. But here you got there's an overlap. Oh, my green is still sticking around. Let's just get rid of this thing and go back to my black. Okay, so there's a underneath this thing, that's what you got, which you can't see. And so yeah, you got a double square. You got a square at the top, at the bottom also you got a square. So the same thing with this. Now, how do you use that fact? The way to use this fact is that the total area covered by the 4 strips, each strip is 10 by 1. So if you multiply the total area of these 4 strips, you're going to get 40. But the only thing is, to find out how much of the table is covered, you have to take away the part here, which is counted twice. This part here is counted twice. Well, it should not be counted. But we have, because we are adding this strip and that strip. So we are, this one here, we counted 1 square centimeter for that. Right? And this one here is counted once. So each one of us counted twice. So these 4 squares, the 4 spaces, were counted twice, and we should have counted them only once in this. So you have to subtract 4 to get 36. That's the area which is covered by these 4 strips on the table, right? The question is, what area of the table is covered, right? So if you work out the area of the 4 strips together, you got too much, because some pieces are covered twice. So you have to remove those which are repeated. That is the bottom line in that formula. So there's your argument here, in case you didn't follow that. Okay, let's get on to the third problem. A palindromic number reads the same from left to right and from right to left. So this number here, if you read it from left to right, 14541, and if you read it from right to left, you'll get 14541. So it's the same thing. So backwards and forwards, it gives you the same thing. In other words, if you write it backwards, you'll come back to the same number. Now there's a palindrome, 15951. It shows on the odometer of your car. In other words, you have traveled 15,951 kilometers, because that shows on the odometer of your car. And you're traveling along with your car. And of course, the odometer, it increases, 15951, 15952, and so on. And it says, how far must you travel before the next palindromic number shows on the odometer? So the question is, what is the number that reads backwards and forward, the next one? Okay, now you notice as you are traveling, these numbers keep increasing. So you got 159. So as long as you are in 15, right, you're at 159, and that's not going to give you a new palindromic number. The next palindromic number will be at 16, right? It has to cross 16,000, and if you want it to be next, you might as well get it as soon as possible. Put 160, and that gives you that palindromic number, because you want it to read same backwards and forwards. So which means this is the number that you're going to go to. If you've got 160, this has to be 6, this has to be 1. So the total distance that you have to travel, you just have to subtract these two, and you get to the answer. So how far must you travel, you see? So you have to travel 110 kilometers. I think if you subtract these two, you get 110. Okay, so that's not very complicated. Oh, there it is. The next one says February 14th, Valentine's Day, was on a Sunday last year, 2021. We're doing 2021 paper. So now what are the last two digits of the first year after 2021 in which Valentine's Day falls on a Sunday? Now these year problems, I think all Olympiad students should have a fairly good idea as how it works, because each year, even if you're not an Olympiad student, you know, if this year, if your birthday was on a Tuesday, then next year it will be on a Wednesday. I think you all know that. And the reason for that is there are 365 days in the year. Right? So how many sevens are there? So you got 52 weeks and 1 day. Right? Work out the number of weeks and days in 365. So in 52 weeks, exactly 52 weeks, your birthday will be on a Tuesday, but it's 1 day more. So your birthday next year, 365 days, will be on a Wednesday. But if you crossed February 29th, if you cross that number, then you would have traveled 366 days. But if you didn't, you don't have to bother, right? In the way you calculate things. So as long as you don't cross February 29th, you'll keep adding 1 day to it. So you want to know which day fell on a Sunday, then you got Sunday, Monday, Tuesday, Wednesday. Oh, maybe not. That is not how we're going to do this. Maybe what we should do is so you look at 2021. The question is, which is the first year? So let's look at what happens. Each year, what happens to that Valentine's Day? I don't know how far you have to go, but space doesn't allow me to go more than that. So here it was on a Tuesday. No, I'm sorry, Sunday. Right. From 21 to 22, there's no leap year. So this will be Monday. From 22 to 23, no leap year, Tuesday. But from 23 to 24, you're going from the 14th of February, that's your Valentine's Day, you're crossing 29th of February. So you're adding 1 more day, right, than necessary. So this goes into the Thursday, Tuesday, right? So it goes to 366 days. So this is Thursday. So we need to come back to a Sunday. So here it's Friday. And you're not crossing the international date line. And here, no, this is 2023. This will still be Wednesday. Sorry, 2023, I'm not crossing. This doesn't have 29 days. So this is Wednesday because you come back to February the 14th. Now this is where you go to a Friday, because from February 14th, this has 29 days. So this crosses the Thursday, this is Friday, Saturday, and you come back to Sunday here. So your Sunday, the first time, Valentine's Day will be on 2027, and the last 2 digits that you're looking for is 27. You must answer the question, what are the last 2 digits of the first year after 2021? After 2021, the first year after 2021, where the Valentine's Day falls on a Sunday, is 2027. And the answer is, the question is, what are the last 2 digits of that year? And the answer is 27. Now remember, always answer the question. A lot of people lose marks because they don't answer the question, although they get very close to it. Well, I've spelled the whole thing out, and you can see here, I'm giving you detailed solutions, which is very good. When you see the video, you'll have all the, it'll be much easier to understand. In this problem, a triangular corner of side length CD equals CE. CD equals CE equals 10. So I'll put the 10s here. Is cut from the equilateral triangle ABC. So this is an equilateral triangle. All the angles are 60 degrees. And they ask you, what is the perimeter of quadrilateral ADEB? So to find the perimeter, you have to find all the sides and add them. Okay, so that doesn't look very hard. But let's see what goes on here. Well, it's an equilateral triangle. The original triangle is an equilateral triangle. So therefore, this side is 30, this is 10. So let's look at the sides of ADEB. Okay, this whole thing is 30. This is 10, so this is 30. The only thing is we don't know what that is. So to find the perimeter, I need to know what this is. I've got 3 sides quite clear. The 4th side, I don't know. All right, well, the important thing here is that this is an isosceles triangle. Therefore, these angles are equal. But this angle is 60 degrees, you see. Because this angle is an angle in the large triangle. And all the angles in the large triangle are 60 degrees. And you've got an isosceles triangle with this vertex angle 60. Those two will add up to 120, and therefore each is 60. We've done a similar calculation earlier on, which means that this triangle is actually equilateral. So if these two are 10, so that thing there must be 10. All the angles are 60 degrees. So there it is. You've got your perimeter. You simply have to add all the sides, the 3 sides of the triangle, and the answer is, the 4 sides, the answer is 90. You add the 4 sides, 30, 30, 20, 10, and you get to the answer. So that's the perimeter. Perimeter means the sum of the 4 sides. Right? So I've written the 4 sides in the diagram, and I've added them mentally. Okay, so the next problem. Problem number 6. How many 3-digit numbers with digits this are divisible by 3? So the question is, you're going to make 3-digit numbers from this. Digits may not be repeated. Okay. So you can actually try to write them down. And you're going to write a 3-digit number. So let's sorry. So let's just draw a 3-digit number. And to draw a 3-digit number, I'm just going to put them in a rectangle like this. Always like to, if you've got digits, I like to see what the hundredths and units are. Okay, you're going to put 3 digits inside here, and they must be chosen from here, and you can't repeat them. So what is the rule for a number to be divisible by 3. So that's the salient thing. You want this number to be divisible by 3. And the way to find out whether a number is divisible by 3 is that the sum of the digits is a multiple of 3. That's the test for divisibility. For a number to be divisible by 3, the sum of the digits must be divisible by 3. So you're taking 3 digits from here, and you want the sum of the digits to be divisible by 3. So if you're taking 3 digits from here, you're leaving 1 out. So let's try leaving each one out. You got 2, 3, 7, 9. Can I leave 2 out? If I leave 2, if I exclude 2 in the 3, then these 3, the sum must be divisible by 3. It doesn't work because that's 19. So you have to include 2. Right? Likewise, if you leave 3 out, no, I'm sorry. Yeah, you can't leave. You can't leave 2 out. And what other number can works? You see, if as far as 3 is concerned, 2 plus 7 plus 9 is okay. So you can have 2, 7, 9. Right? And all the variations of that. If you leave 9 out, you got 2, 3, 7, because that gives you 12. But if you leave 2 out, 3, 7, 9 wouldn't work. Right? So you can't have 3, 7, 9. That's out. And you can't have, the other one is 2, 3, 9. You can't, where you leave 7 out. So these are the only possibilities. Right? So you want to know how many 3-digit numbers you can make? Well, from 2, 7, 9, you can make 6 2-digit numbers. Right? 2, 7, 9. Right? And there are 6 different numbers you can make. 2, 7, 9, 2, 9, 7. 7, 2, 9, 7, 9, 2. 9, 2, 7, 9, 7, 2. You can start with 2 or 7 or 9. And in each case, 2 or 7 or 9, each case you can flick the other 2 numbers around. So you got 6 numbers that are produced here. And another 6 numbers are produced here. So the answer is 12. So what I'm saying is that you can use 2, 7, 9 and all the variations. That gives you 6. Or you can have 2, 3, 7 and all the variations for that. And those are the only 2 situations you have. And there'll be 6 different numbers there, and you have 6 different numbers here. When you change them around, the sum still remains 12. That's the point. So all these numbers will give you divisible by 3. So the total number is 12. Okay. Get to the next one, problem 7. Okay, I'm at 6 o'clock here now, but I'm going to just do these ones are not so difficult. So I'll just eliminate them quickly. Here, what is the difference between 2 prime numbers that add up to 1 less than the largest perfect cube less than 100? All right, now let's just try to unravel that other thing. You got 2 prime numbers that add up to 1 less than the largest perfect cube less than 100. So you have to understand what this is. First, try to see which is the largest perfect cube, which is less than 100. You got 2 cubed, you got 3 cubed, and you got 4 cubed, and you got 5 cubed. Which is the largest perfect cube? This is 8. This is 27. It's still less than 100. The 64 is still less than 100, but this is 125. 4 cubed is 64, right? So the largest perfect cube, which is less than 100, is this. Largest cube, less than 100. Right. Now, you want these two prime numbers to add up to one less than that. So one less is 63. Right. Now you want the two prime numbers to add up to 63. So you got, let the numbers be A and B if you like. The prime numbers. You want the sum. These two prime numbers, they add up. So when you add them, add these two prime numbers, you're going to get one less, which turns out to be 63. So you got the sum of two prime numbers, 63. You might think now, hey, there's a lot of possible answers to this, because there are lots of prime numbers less than 63, right? 3 and 7 and 11, 37 and so on. So which are the two numbers which give you this? Now at this stage here, now watch, listen very carefully. When you have the sum of two numbers equal to an odd number, one of them must be even. Let me just say, when you have an odd number plus odd number, that gives you an even number. Agreed? When you add two odds. Likewise, if you add an even number to an even number, you're going to get even again. But you're adding these two numbers and you're getting an odd number. So what does it mean? It means that you can't have both odd. This is excluded. You can't have both even. So you have to have one of them is even and one of them is odd. It forces that. But they are prime numbers, and there's only one even prime number, right? And there's only one even prime number, and that is 2 is the only even. So it's not as if you got lots of possibilities, right? You can ignore that because you only got one of the numbers has to be 2, and the other one is 61. 2 plus 61 is 63, and it turns out that that is a prime number. So the numbers that you're looking at are 2 and 61. And the question is, what is the difference between these two? Answer the question. So it's 61 minus 2, which is 59. So the answer to the question is 59, because you want the difference between the two prime numbers that add up to one less than the largest perfect cube less than 100. It's a mouthful. When you read this, it's an absolute mouthful. So you read it piecemeal. First you say, what is the largest perfect cube less than 100? Right, we've got it. Then one less, we got it. Now you say, what is the difference between the two prime numbers that add up to this? So you want two prime numbers to add up to this. We give names to them, right? And you want to see what are these numbers. They add up to 63. But now this is an odd number. When you got two numbers which add up to an odd number, one of them must be even and the other is odd. You can never have even plus even or odd plus odd. Right? Both of them give you even. It's a very important fact. If the sum of two numbers is odd, then one of them is even, one of them is odd. But the only even prime number is 2. So therefore, one of them is 2 and the other is 61. And then finally you say, what is the difference between those two? 61 minus 2, and that is it. Okay, so I think I'm going to stop there because we've got a lot of problems to work out the next week because it's already, I don't know, it's 6:05. Even this one, I'm not going to do this. You can try this thing out. This one here you can try as homework. It's very easy. Now here you're writing this is the difference of two prime numbers. What is the largest difference? Again, you can check this out. Try out various possibilities and see which is the largest difference. So I'm not going to give you that. And here, right. So you can try out these problems. These problems are a little bit challenging, but not that difficult. But as you go down the line, then it becomes more and more difficult. Okay, so I'm going to stop there. In other words, I'm going to start at problem 9, problem 8, because I'm going to give you, I want you to try these. In fact, from problem 9 to problem 25, you can try all of them and see how many you can do, because next week is going to be the last week. You can ask yourself how prepared are you for round 2. But if you can't do many of them, don't feel too bad about it, because vast majority of students, I can tell you that out of those 25 problems, 25, there will be just maybe 5% of the students will get maybe 9 or more out of the 25. So don't feel too bad. I'm doing the whole 25. So that's really a big, you're not expected to know all of them, but for your edification, I am doing a whole lot. So I'm training you to do even rather difficult problems. So next week, even if you fail with those, don't feel too bad. Just look forward to coming here next week so that you can solve. You'll know the answers to the problems. Okay, so I'm going to stop there. It's 8 minutes past 8, and I'm going to switch off my microphone.